Looks good, Alyssa?
We are live.
Beautiful. Hello and welcome. My name is Valerie Burke, and I'm the Assistant Dean for Graduate Student Services here in the college, in the Graduate College at UNLV. And I am thrilled to welcome you to our 10th annual Rebel Grad Slam 3-minute thesis competition. The 3-minute thesis, or 3MT competition model, was developed at the University of Queensland in Australia in 2008. It spread to other universities in Australia and New Zealand in 2009 and 2010. By 2011, the 3MT competition phenomenon had spread around the globe, and now more than 600 universities from more than 65 countries hold these competitions. In 2014, UNLV held our first 3MT, the Rebel Grad Slam, and this year is our 10th annual Research Rumble. The 3MT is a fantastic opportunity for students to learn how to convey who they are, what they study, why they study it, how they study it, and what they found or expect to find, and why it matters to an audience of folks who are mostly outside their field. It's an opportunity to build public speaking and communication skills and to polish one's elevator speech describing what they study as graduate students. It's worth noting that our slammers come from all over campus and from a wide range of disciplines. Some are first-year students, some are in their final year. Some slammers are master's students, others are advanced doctoral candidates. It's a diverse pool of over 90 graduate students competing here this week. So today we have a group of UNLV graduate students have been randomly assigned to compete in this preliminary session. Each will present their research in 3 minutes or less using one slide and no props. We will introduce each student and then start the timer. If a student goes over 3 minutes, they will be eliminated from the competition. Slammers are encouraged to pace themselves and use their 3 minutes without going over. It's easy. It's not easy, but it's what the 3MT is all about. Slammers, please make sure to keep your microphone on mute and video off when other competitors are presenting. Only turn on your microphone and video when you are presenting. Please be sure to stay for the entire session, even after you are done presenting. If you have any questions, please type them in the chat in between presenters. Please do not use the chat during anyone's presentation, as it may be distracting. You may sit or stand while presenting. You have 2 minutes and 59 seconds and one chance to compete. After I introduce you, our Zoom host will advance to your presentation slide. You may then begin your presentation. Once you begin speaking, we will start the timer and you will not be able to restart your presentation unless something beyond your control occurs. You will be able to see the Zoom timer on your screen on the upper right-hand side. Please don't stop unless I stop you. Don't worry though, if you lose Wi-Fi or are disconnected, please join back in. We will wait a minute for you and then go on to the next presenter. If that happens, you can redo your presentation at the end. And please remember that you may not read your presentation or use any notes on your screen or in front of you. Now, let's turn our attention to the scoring for the Research Rumble. The judges will be assessing the competitors based on metrics, which total 24 possible points in 4 major areas: comprehension, content, engagement, and communication. Each judge will independently score each competitor. Judges will not penalize competitors for unanticipated disruptions that are beyond the slammer's control. At the end of the presentations, we will tally the judges' combined scores for each grad slammer and announce the winners right here live. The top 3 in this session will advance to the semifinals. I'd like to note that this round of the competition is happening live in Zoom and will be simultaneously aired live on the Graduate College's YouTube channel. And to give you a sense of this year's competition, over 90 students are competing in the preliminary rounds. Around 36 will move on to the semifinals, and only about 9 will advance to the finals, which will be held at 4 p.m. this Friday, December 1st. So without further ado, let me introduce our judges, and then we will get on to our 3MT Research Rumble. We have a set of very distinguished judges here in this session. Let me grab this list. Okay, we have Monica Nita from the College of Sciences, Annie Wiseman from the School of Medicine, Jeff Orgera from the Vice Provost for Academic Affairs Office, Nicole Leland from the Division of Health Sciences, and Rachel Robinett from the College of Liberal Arts, and John Hirano from US Bank. And I'd also like to take a second to the Graduate College would like to say a special thank you to US Bank for generously sponsoring our Rebel Grad Slam event. So we appreciate that and thank you very much. My script back here. Welcome and thank you for serving on our panel of judges today. So we are ready to begin the competition. Our first presenter is Rachel Langen. I can see you. Yes, I see you. Rachel is a Doctor of Philosophy student in astronomy. The advisor is Dr. Carl John Haster. And Rachel, I'm now going to turn it over to you.
Good morning, everyone. Gravitational waves are often described as ripples in our space-time, physically stretching and squeezing the world that we live in. These waves are akin to dropping a pebble in a pond and observing the ripples radiating out across the water's surface. In 2015, here on Earth, the Laser Interferometer Gravitational Wave Observatory, LIGO, shown here on the right side of the screen, located in Hanford, Washington, and in Livingston, Louisiana, detected this stretching and squeezing of our space-time. It was first predicted in 1916 and expressed by Einstein's field equations in his theory of general relativity, and thus the observation of the first gravitational waves only generated by a low-mass binary black hole merger led to the awarding of the Nobel Prize in Physics to LIGO in 2017, just 2 years after their first observation. Now, in 2023, various international collaborations, such as NanoGrav, have used the pulsar timing array shown on the left side of the screen. This array comprises of incredibly dense, rapidly rotating neutron stars known as pulsars, which emit beams of electromagnetic radiation, and we could think of them as astronomical lighthouses. In this case, a network of pulsars functioned as a cosmic clock, and differences in the arrival times of their signals over a 15-year period found evidence for a gravitational wave background that permeates throughout our universe. By the following decade, next-generation and space-based observatories, like the Laser Interferometer Space Antenna, LISA, shown on the middle of the screen, with budgets in the billions of dollars, will come online with the aim of detecting merging supermassive black hole binaries in the frequency middle ground shown below. Notably, all of these efforts have one thing in common. Across all frequencies, the models used to describe these waves, called waveforms, are not fully understood by astrophysicists, and this is where my project comes in. Throughout the past semester, I have tested our best waveforms on 2 different binary black hole simulations at various detector sensitivities, and we have continually found that as we advance our detector networks, the parameters recovered by our best waveforms still yield biased and inaccurate results. Thus, to address these issues and to be ready to reap all of the scientific benefits of next-generation gravitational wave detectors in the 2030s, waveform models that are significantly more complete and accurate need to be developed in the next decade for us to better understand some of the most fascinating sources in our universe. Thank you all so much for listening.
Thank you, Rachel. We will now give our judges about 60 seconds. Let's see here. I do have a note that says, if we can ask the judges to make sure they put ones in the rubric as it's a mandatory field and we can't just skip participants. Okay, so if we have anybody that is judges that are on your rubric that don't have a slide, they may have dropped at the last minute, but we can't just, you can't skip the slide. So you can't skip the judging rubric. So if you just put ones in there, we'll know that that was for somebody that wasn't able to make it.
Did you know that now you can use AI in Adobe?
Okay, our judges are finishing up and we will advance to the next slide. Second. Okay, next up we have Jeffrey Ash. Let's see if I can see Jeffrey. There they are. Okay, Jeffrey, I am going to turn it over to you. Go ahead.
Hello, everyone. Today's presentation is on the iodine-mediated anionic fluorination using fluoride salts for phosphorus-fluorine bond construction. So the problem with known methods for phosphorus-fluorine bond construction in the literature is that they are not environmentally friendly or sustainable. The known methods use metal catalysis or pre-functionalized reagents, which is not desirable. Also, the known methods are not cost-effective as they use expensive electrophilic fluorinating reagents such as select fluor. The motivation behind the study is that many small molecules that contain this structural motif are very useful. They have been used for the treatment of cancer, the treatment of glaucoma, enzyme inhibitors, and even chemical weapons. So our hypothesis was, how can we develop a more environmentally friendly phosphorus fluorine bond forming reaction that is driven by electricity? So instead of using metal catalysis, electrons in the form of electricity will be the driving force for this reaction. But this hypothesis isn't testable. So our testable hypothesis was, can we use iodine as an electron mediator to develop a nucleophilic electrochemical fluorination reaction? So some of the challenges early on in this project was the low nucleophilicity of fluoride. Fluorine is very electronegative, so it's stable and unreactive. So to overcome this challenge, we use polyethylene glycol. This chelates the metal cation of the fluoride and allows the fluoride to react. The final product was not stable, so we had to make sure that all of our reagents were free of water, and we had to make sure that the potential of the cell remained low so it wouldn't ruin the working electrode. So to do this, we use a solvent that has a high dielectric constant. It conducts charge well, such as acetonitrile, and we used a lot of supporting electrolyte to facilitate the charge between the anode and the cathode. Another major challenge was passivation of the working electrode, which occurred when lots of cesium fluoride was being used. So to prevent this, we used cesium fluoride as the limiting reagent. So overall, the reaction worked well with secondary phosphine oxides that contain donating and withdrawing groups, as well as alkyl secondary phosphine oxides. Lastly, we did a cyclic voltammetry study to study the redox behavior of all the reagents. The main finding from this study was that iodine is needed for oxidation. So without iodine, no reaction occurs. So overall, we developed a more green and environmentally friendly electrochemical synthetic methodology to form phosphorus fluorine bonds. All right, thank you.
Thank you, Jeffrey. We will now play a little music to give our judges a minute.
I think I had like 20 seconds.
Thank you, judges. We are up to slammer number 3. Is Daniel's video on? I see you, Daniel. Perfect. I will now turn it over to you.
Thank you, Valerie. This presentation is titled Unleashing the Potential, Measuring and Testing Fusion Power Electronics. Imagine a small seed. Within it lies the blueprint of a tree, vast and mighty. Now, imagine this seed is much like the boundless potential of fusion energy, the same energy that powers the stars. Today, we're on a journey not just to tap into this potential, but to harness it safely and efficiently for our future. In the next few minutes, I'll take you through the exciting process of how we measure and test the robust electronics that will bring the power of the stars to our fingertips. Our sun, a colossal fusion reactor, demonstrates the raw power of fusion. Our mission, to replicate this stellar process to power our civilization. But with great power comes great responsibility. We must first measure the invisible yet mighty force of radiation, mapped here as it varies with altitude, ensuring we can protect and optimize our fusion detectors and future space electronics. Our answer lies here in this marvel of engineering, the Hull Room, a fusion fuel capsule made of gold and 192 focus lasers that mimic the heart's sun. Here, in the fusion of deuterium tritium, similar to DD fusion, we can unlock the neutron energy, each collision a step towards cleaner tomorrow. Still, this process must be measured with diagnostic equipment. These aren't just simple silicon electronics. They are the vanguard against the fury of fusion-generated radiation. The gallium oxide crystal semiconductor here stands resilient and transparent, a testament to our ingenuity safeguarding the dream of a world powered by the stars. When exposed to invisible radiation, the crystal glows bright, a key indicator which is safely visible by remote camera. As we capture the ballet of neutrons over time, our understanding deepens. Data captured last month from New Mexico's Los Alamos National Lab Neutron Science Center, or LANCE, gives us a window into the temporal behavior of the energy so potent it can one day light up an entire city on Earth. Analyzing this spectrum of neutron energies is like listening to a symphony of the cosmos, each peak and valley in harmony of fusion that could sing us into an era of unprecedented clean energy. From sun to sensor, from seed to tree, we are not just measuring and testing, we are growing a future where fusion energy lights our way. This is our quest, to turn the potential of fusion energy into a tangible reality, a gift of light for generations to come. As we stand here on the brink of dawn, I invite you to envision, how will this energy shape our future? And what will you do when you have this energy of the stars at our grasp? Thank you for your attention.
Thank you, Daniel.
Study.
Okay, we are ready for our next slammer. And I see Keone is ready. Your video is working great, so I will turn it over to you. Thank you.
Every year, millions of people around the world are affected by infectious disease. Whether it's something relatively mild, like the common cold, seen here in Figure 1, or something decidedly more dangerous, like tuberculosis, measles, or malaria, infectious diseases can have a devastating impact on our normal everyday routines. Adults take time off work, and children stay home from school, but despite all of that, these diseases continue to spread throughout the population and can often be difficult to control. As an applied mathematician, I offer a unique perspective to this issue. Mathematical models can be used to help us better understand how these diseases can spread. One example of such a model is seen here in Figure 2. This is the susceptible infected susceptible model, or SIS model, where the population is split into two groups. The susceptible group are those that do not have the disease, but can be infected with the disease, in which case they move from the susceptible group to the infected group. The infected group are those that do have the disease, but can eventually recover from the disease, going back into the susceptible group. I actually study a special version of the SIS model, which takes into account population movement. As suggested in Figure 3, we live in a highly interconnected society where people are always on the move, going from city to city, country to country. Additionally, on a daily basis, we go from school to work to the gym to the grocery store. We are constantly moving around and interacting with the people around us. We want to use our mathematical models to help better understand how this type of population movement can affect the behavior of a disease once it is out in the public. The ideal scenario is seen here in Figure 4. The x-axis represents time, while the y-axis represents the number of infected people. And we can see that as time goes on, the number of infected people goes down to 0. This is called extinction. Using the power of mathematical analysis, I can determine the precise set of parameters for the map model that allow us to determine when the disease will be led to extinction. For example, if your population size is small enough and you completely restrict the movement of the susceptible group but leave the infected group free to move, then your disease will be driven to extinction. Results like these can help us get a better idea of the expected behavior of a disease so that we can keep people healthy during the cold and flu season, or perhaps even prevent the next pandemic from happening. Thank you.
Thank you. We will now give some time to our judges. Okay, we are ready for our next slammer, Jennifer Fletcher. And I see your video there, Jennifer. I will now turn it over to you.
Hello. So my program is research with a community partnership. The the TPOP program on truancy prevention in Clark County, Nevada. So what is truancy prevention? Well, first you have to understand what truancy is. Truancy is unexcused absences from your school. In the state of Nevada, you are considered truant if you miss more than 7 days of school in 1 month. That is unexcused. So truancy prevention is lowering truancy rates, which in Nevada are very prevalent. So in Clark County, Nevada, the Department of Juvenile Justice created the Truancy Prevention Outreach Program, or commonly known as TPOP. They reached out to UNLV's College of Education and wanted us to help with their statistics to understand if TPOP was effective. Their program started in 2020, as well as our partnership with them. The goals of the program are to lower truancy rates in Clark County, as well as improve academic performance. So that's where our quantitative data comes from, is looking at change in attendance rates after a student has been entered into the TPOP protocol. We found in our analysis that 15 of 22 points of research are statistically significant, that TPOP is effective in lowering truancy rates in Clark County. It also is effective in helping to raise standardized testing scores and lowering the number of classes failed per student. From there, we also looked at qualitative data that came from the case notes of the community navigators who work directly with the families. The program aims to help lower truancy at the family level and provide resources for the families to lower their truancy rates. The code system, as you can see, those are our parent codes, and each parent code has a couple of child codes that analyze parts of conversations between families and case managers. This qualitative data is also being used in a mixed methods analysis, which preliminary results so far are showing that families who have positive reactions to TPOP are more likely to succeed in lowering their truancy rates with their students, as well as the opposite is true, that negative reactions are show that families are less likely to succeed through TPOP. The benefits to UNLV with this program is that it is a community program with the Department of Juvenile Justice, and that is something that UNLV aims to improve is community-based research. It also helps the community because truancy has been found to directly relate to increased risks of juvenile delinquency and injury with youth. And so if students are not truant, they're less likely to be in trouble with the law. Future research is looking more into the case notes that we have been provided, which were over 33,000 analyzed, and getting more information from that and expanding the truancy prevention outreach program.
Thank you, Jennifer. Okay, we are ready for our next slammer, and I see Maisie is ready as well. So I will now turn it over to you.
Of all students arrested in schools or referred to law enforcement are Black or brown. This 1% paints the exact picture of what I saw play out in 2 schools across the country. I taught high school science for 5 years, 2 years in Birmingham, Alabama, and 3 years here in Las Vegas. And although they're very different geographically, I saw the same thing play out discipline-wise. I saw my same students be pulled from class and sent to the behavior office. I saw my same students miss weeks of school at a time for suspensions and juvenile assignments. And I watched my same students, my Black and brown students, be disproportionately disciplined, surveilled, monitored, restrained, pepper sprayed, and put into a police car out my classroom window. What I'm describing to you is called the school to prison pipeline. This social phenomenon consists of educational policies, practices, and institutions that disproportionately push students of color out of schools and into the hands of law enforcement. Many teachers today have to go through very strenuous preparation programs. They're introduced to things like multicultural education and restorative justice practices, but very few of them are aware of the systemic racism present within our current educational model. I wanted to know what teachers know about the school to prison pipeline and how they see it playing out in their own space. I conducted a teacher survey and I found 4 major themes. Number 1, teachers could definitely identify racial disparities within the school to prison pipeline, but they had trouble connecting it back to the discipline practice within their own high schools. Second, teachers had trouble identifying alternative pathways for students that had interacted with drugs and violence other than the juvenile system, even though there were already tons of things in place. Third, teachers felt that it was appropriate to refer their students to law enforcement, even though the same teachers didn't think it was beneficial to students' success or academic achievement to be placed in alternative school or the juvenile program. And lastly, teachers solely assigned blame for this phenomenon onto the students, never once addressing lack of teacher preparedness. Our teachers need better preparation to face the systemic racism built into our current education model. Our teachers' preparation programs need to evolve and able to meet the needs and current issues of our students in schools. And lastly, these teachers need support, resources, and the confidence to identify and call out injustice, racially biased discipline, and to be advocates the students need when they're being treated like prisoners within their own schools. Thank you.
Thank you. We will now turn it over to our judges for a minute.
Black Friday is your chance to snap.
Okay, I believe this next slammer is not here. Daylight? So for my judges, this is what I was referencing before, where I believe their judging rubric pops up, and you just have to put all ones in and then hit submit. So that way you can skip them and we can go on to Elizabeth. Judges, if you have any questions or that doesn't make sense, or you're not seeing what I'm seeing, go ahead and put it in the chat. And I think we are good. So I'm going to move on to our next slammer. Elizabeth, I see your video is working perfect, so I'm going to turn it over to you now. Great.
Fantastic. Good morning. I'm going to talk today about memory and some strategies we might be able to teach to enhance it. So memory is a fundamental function of our brain. It's a fundamental component of learning. The information we learn, the skills that we have are all stored and maintained and expressed by memory. Memory has multiple systems. I study one called the working memory system. The working memory system has 4 components. One, the phonological loop, where information that is written or verbally heard is stored. The visuospatial sketchpad, where information that we see and where it is stored. The episodic buffer, which combines information from those 2 systems, the verbal and visual, into one piece, and the central executive, which acts as a control system that directs information and attention to where it needs to go between those 3 subsystems. There are multiple strategies that we can use to enhance our memory. The most common is repetition and rehearsal. Another is using a memory device like a mnemonic, making like an acronym, for example, is usually helpful. Another option is using something called dual coding. Dual coding is when information is presented in a way that activates both that verbal and visual system at the same time. This is like a trigger. Something has triggered those 2 systems to work together to use both of their resources and maybe enhance our memory. The word cat is a great example of this. If we see cat in a vocabulary list, we have a written or verbal stimuli activating that verbal system. We might picture a cat, orange cat, black cat, any color cat. It doesn't matter. We now have a visual stimuli activating that visual system. They might activate together, maybe in that episodic buffer, and have better recall for that word. This is great for words that have very specific concrete images, but not all words do. We often have abstract words that don't have specific images, maybe like the word jaundice. With this word, we should use another memory strategy called the keyword method, where we visualize something to associate with that word that might be silly or funny, but helps us remember it. Jaundice kind of sounds like the word juice, and someone's skin might start to turn orange when they have jaundice. So maybe we picture somebody drinking orange juice to remember the word jaundice. My research goal is to teach these 2 strategies to individuals and see if it helps enhance their memory and maybe provide support for that episodic buffer where information is integrated from the 2 systems into one piece. I hypothesize that my research will increase people's overall recall and will provide that support for that episodic buffer. Thank you so much for your time and have a wonderful day.
Thank you. Now we'll give our judges 60 seconds. While the music is a little quieter, I just wanted to let y'all know that we are tallying up all of the scores right now. So I want to thank you all so much for joining our preliminary rounds. A special thank you to the Grad Academy team who have made this 3MT event possible. Now, just stay tuned. We will announce our winners live in just a few minutes.
This is Lauren. So are we ready to finance this beauty? Don't say the F word around my
Okay, and I am back with the announcement of our winners. So while only the top 3 winners of this round will progress to the semifinals, you will all be winners of a Rebel Grad Slam t-shirt, which you can pick up during the Rebel Grad Slam finals and reception. Let's see here. I am ready to announce for this preliminary round our 3rd place winner, who will receive a $100 scholarship, is Maisie Dias, presented on School to Prison Pipeline, A Teacher's Perspective. Congratulations. Our 2nd place winner, who will receive a $200 scholarship, is Rachel Langen. Gravitational Waveform Accuracy Requirements was her presentation. And in 1st place, this winner will receive a $300 scholarship, and that is Elizabeth Hofschult Collins, who presented on Exploring the Effects of Dual Coding Instruction. Let's see. So thank you again. Congratulations. I know it's not easy to get out here and do this. So congratulations to all of you. A special congrats to our top 3 winners. And thank you again for your participation. We hope you will all join us at the semifinal rounds, which will be on Thursday, November 30th. And we'll have a session at 9 a.m., 11 a.m., and 1:30. All 3 will be held in the Student Union Cohen Theater, and the finals will be held on Friday, December 1st at 4 p.m. in the Greenspun Auditorium. Lastly, we will have your Rebel Grad Slam t-shirts available at the finals reception at 5 o'clock in the Greenspun lobby. We welcome everyone to RSVP to the finals event, and I'm going to put that in the chat right now. So in the chat, you will find the RSVP link. It's loading. 1 second. Okay, so everyone can RSVP to the finals there. If anybody has any questions, please let me know. And thank you all again for today, our slammers and our judges, and we hope to see you at a future round. Have a great day.